Hello everyone, it's TK here, and I'm going to do a documentation on how to boot up our Bearly research chip. It's very unstable and it's very hard to get it work. I managed to find a boot up sequence, like power on sequence, to make it work more reliably. And at least like now I can run the multi-core Hello World program. So I'm going to document it down, the entire boot up process. So let's shut down everything. Okay, so firstly the setup. This is the chip, it's on a Breakout board. I'm using this power supply to provide 0.8 and 1.8 volt power rails. 0.8 it's the core voltage, and the current draw it's pretty large, so I'm using like 60 milliamp current limit. Some chips can draw up to 50 milliamps, so that's about the threshold. 1.8 barely draws any current, so like the resolution here is not fine enough, so it will show like current draw with 0 amps. And here is the rest of the setup. There's a reset button. This is the boot select switch. When shift to middle, it's the boot from SPI. And here's the level shifter. The SPI signals are shifted through it. It's a bidirectional one. And the other end is a 3.3 volt rail, which is provided by STM32. The STM32 also provides a currently 500 kilohertz clock with the on-chip PWM module, and the clock is level shifted before sending out to Bearly. And the SPI and it's connected to this SPI flash. So I'm probing the three output signals, and I should also probe the return signal, the meso signal here. Yeah, and because the MOSI pin is its polarity is inversed, so we need also to use the FPGA to basically a NOT gate to correct the signal. Okay, so power on sequence. Firstly, we power on the 3.3 volt domain, which is the STM32, and it's powering up the FPGA and the flash via this USB. So power on. We can see STM is power on, and we need to wait until the FPGA loads its bit stream from the flash. With like when these two LEDs lights on, that means it's ready. And then let's restart the logic analyzer. And then we power on the 1.8 volt. Okay, we can see there's clock and nothing else. And remember to press the reset button. And then we lastly we power on the 0.8 volt rail. And the signal should change because the logic is up. And then we release the reset. Okay, so this is a failed attempt. It prints out the core 0 wake up, but somehow the program is stuck and we need to try again. So reset again and release. Okay, and now it's working. Oh, okay, it's not working. It's only powering up core 0. Okay, let's try again. Reset. And coming out of reset. Okay, now it's working. Yeah. Okay, so this is how you power up the Bearly chip for now.